Hello, Barcelona. So yeah, I'm Ruben Bridgewater. I'm one of the most active Node.js core collaborators, and I work as a Node.js consultant and software architect. When consulting companies, I often see companies struggling with errors. Then that's actually a big problem. But the question is actually, why is it so difficult in JavaScript to deal with your errors? One of those reasons is that JavaScript has, other than other languages, the asynchronous nature. So we've all seen stack traces that were pretty useless, where you had no idea where your original call was coming from. And you got some weird stack frames that you could not correlate to the actual code. And there is more to it. So JavaScript errors is something that is not the only thing that you can throw. You're able to throw any data type in JavaScript. That's not possible in other languages. You're very much limited in the way how you're able to deal with your errors in other languages. JavaScript is just very open about it. And we've all seen callback-based APIs. Well, I actually just did not add any callbacks here, and that was a legitimate code until Node.js 8. So people just had fire and forget commands where you had race conditions in there, where you had lots of problems because you did not deal with your errors. And this very, very likely failed because the first command did not finish when the second started, but you never knew if it was successful or not. And here we solved the race condition because we used the callback for the first call, but still we have no idea if the file folder was created or not. And that's a problem, because then the second call will also fail, but you ignore the error again. If we do error handling with the callbacks, you also have to make sure to always have the error first way of doing this. And not everyone always does it right. Sometimes they might check for actual data coming back instead, and that's super bad because some APIs might not return anything or have like a falsy value at times as a valid return value. So you end up in the error case even though you actually had a successful call. So all these cases are bad because they eat away your errors. You have no idea what's really happening in your code, and we want to prevent that. Luckily, we don't really use callbacks anymore in our code, and we use promises. Promises are great, right? We like them because they help us a lot. But with regular promises, we also have to be very careful how to write them. In this case, there is no return statement, and we are branching off the promise chain in a way that we create a new promise chain, and that one is not handled. If the write file command is going to result in a rejection, this is not caught in the catch clause. And we also know the callback hell. But this is also possible with promises. I've seen code like that, where people were handling their errors in place all the time, and it's really difficult to deal with that. Instead, you want to normally handle your errors in a single spot and be done with it. That's why we love promises, actually, because you can nest them and still handle the errors on the top. But promises are difficult. They're really difficult, especially when we use new promise, when you use the promise constructor, because it could result in some cases where we never resolve. Like here, if arg is not true and we don't have an error from the do-something function, then this promise will just hang around and will do nothing. It's a memory leak in your application. So promisifying an API on your own from a callback-based API is something that a lot of people struggle with as well. And a promise constructor has more difficult things, because as soon as it is either rejected or resolved, it cannot get another state. A promise always has a single state. Either it is pending, or it is resolved, or it is rejected. But the promise constructor is a kind of a dead zone. As soon as you resolved or rejected it, any following synchronous error is just swallowed completely. You will not know anything about this error in your regular code. And that's super bad, because it can have a lot of side effects that you're not aware of, and you will not notice this at all. And this will probably exhibit an error later on in other code that you don't know how to correlate again. Let's go to some more real-world examples, though, instead of those made-up ones. So I've often seen companies where they try to improve an error from an API that they just received from. And they added a string to the received error. And what happens in that case is that you run toString on the error. And when you do that, you lose all the important information from that error. Any extra property on that object is gone. And also the stack trace is not visible anymore. What you have is a string that contains your string plus the error string about the error message and the error name. But that's not enough to debug your application, because normally you need to know in what code line your error actually occurred. So mostly it is best to either just keep the error as it is without manipulating it at all, or to wrap it in an own error that you create and just attach that error as a property on yours. And we've all seen REST APIs, and people are dealing with them in different ways. But people just often ignore the actual error. So here, they are just making up what actually happened during this database call. And that means they are logging it's a 500 also to the user, but it could have been a bad request error, for example. It could have been malformed data that the user sent to your API, and that was the reason why the database call failed. And that's a very common thing, you know, that's actually sometimes happening because sometimes your front end might have a bug, and it is sending the malformed data on its own. And the user will have no idea what actually happened, and you have no idea what actually happened either, and debugging is just really, really painful. We are ending up in a debugging horror. We have such wasted hours on finding the actual problem. And you're not only wasting your personal time, but also the money of the company you're working for. Let's go to testing. So mostly we know that testing is really good. We want to test our code. Otherwise, this is also really difficult to refactor your code without running into some edge cases, and because we have limited capacity in thinking about all the different states of our application at a time. Tests help us in this case. But if you only test for the positive things, then this is not enough. That's what I've often seen. So people have an expectation for the API, what it should return, and they will write tests to test exactly those positive things. But if you don't test for the bad things as well, so for example, if you have an input that is invalid for this API, then you will run into problems during production. And if you're running in production into those problems, that's much worse than during development, because it can cost you a lot of money, a lot of debugging time that you have to spend into it. So please always make sure to test not only the positive things, but also all the edge cases, all the error cases. It's super important. And sometimes people use try-catch in tests. When they do, well, sometimes they just don't verify that the expectation is actually met. This is also occurring in Node Core itself. We just refactored our code completely to remove that pattern and to make sure that we always have an error when we expect it. Because if API ABC is not throwing an error, as it is here 50% of the time, then the catch clause is not triggered, and we will not know about it. The test will still pass. And it's a super simple thing to do, but somehow we still forget to actually look into that. And this is a code that I had to review a while ago. It has multiple problems because this is a database call where you have to have a rollback in some case, so there are no transactions involved, and it means that you sometimes have to manually rewind your changes if there is an error happening during your call. But the problem here is, let's go through it. We have this validation function on top in a try-catch, and then we end up in this catch clause. We manipulate the error message, we add something to it, and then we call this rollback function. But why do we call a rollback? We've never even started to hit the database. And then if the rollback throws an error, we will not even know that it was a validation error, and that's pretty likely in this case. So we will just hear that the rollback function threw. That's all you would know in this case, because throw error would not be reached anymore. That's not the worst case in this here. Like, let's go into a try. So they are wrapping try catches, which is mostly a very bad idea. We normally try to limit the usage of a try catch in general to minify the surface where you have to handle your errors. It makes your life easier. So here we make our actual database call. So the input was valid. And afterwards, we manipulate the error message again, and we say it's inner error plus the original error message. And then we add a property to it and say it's of a specific class that it already is a class of. It doesn't really make any sense. So we tend to provide more information that is already there. But why don't we just accept the information that is there? I've really seen this multiple times. And now we throw that error, we manipulate the error message again, so it would be like, could not do things, inner error, plus the original error message. And it's just very verbose without really helping you out. So concatenating the error message will probably not help you. And this is an example how I would write it instead. I would only wrap this in try-catch in the catch clause. Because in the catch clause, there might be something going on with the rollback for whatever reasons, and you still want to know about that rollback error. So you personally log it to look into that problem, because this should never, ever be a problem if you end up in that case. And then you throw your original received error. That means you don't lose the information that your original database call was the problem. And every one of you who used promises before has probably run into some unhandled rejections. So in Node, we provide you with an error message or a warning that something like this occurred. On the front-end side, that's not available like that, but there is even a hook, as far as I know, to also receive a notification if something like that happens on the front-end side. And this means you reject it somewhere, but your application is going to continue to run. Because if there is a regular exception, your application is going to stop and not continue to run, which is mostly good. Then we can just start the application again and have a fine state. Because most applications have a kind of state, right? And we can run into these unhandled rejections very frequently, and with code where you don't know that it actually triggers it, because it looks fine. Here, for example, we handle our promises one after the other. The problem is, as soon as we await A and that rejected, because A is foobar is throwing an error, so that means it's going to be rejected promise. And now we are handling it in the try-catch, and we are ending up in the catch block. Await B is never reached. And that means it's an unhandled rejection if the promise rejected. And what we can do instead is to have promise all to handle those in one step. And sometimes it looks even worse, because this example, for me, looks pretty good. It was a pull request where someone removed a word from this example. So this is the pull request where this word is removed. Why is this actually ending up in an unhandled rejection? Because we are returning the promise before we are handling it with a try-catch. So we have to await the function that throws, the async function that rejects, sorry. Otherwise, it will never end up in a catch clause. And there's probably a lot of code out there where these patterns occur without anyone really noticing it. So it's really important to always look into that. Let's not only talk about all these negative things. We want to know how we can actually overcome problems like that, how to make our lives easier. And I want to show you a couple of patterns that are very easy to implement. And I'm starting an application with an application error class. That way, I know all errors in my application that I explicitly throw are going to inherit from it. And I inherit a couple of other ones from that, because there are normally different layers in your application where you have to deal with problems, where you have to deal with explicit errors. Some of those are user-facing, for example, a REST API. Some of those are database errors. Those are normally not user-facing. Actually, they should normally be handled transparently to the user, which means they have no idea that something in the background went wrong. And that's good. We are able to distinguish our errors if we use those error classes. And we can do more with them. So now I make a new error class that is called, for example, bad request error and not found error. And those inherit from the user-facing error. If I throw one of these in the code and say, throw bad request error, every developer is going to understand what is going on at that point of time, if they read the code. And you're able to pass through multiple additional options or properties to that error during instantiation. That's good, because you probably want to add a couple of more information to it. You can also have properties that are always there, like a status code, so you don't have to think about it anymore. If you receive a user-facing error, you would immediately know that the status code is always part of this error class, and you can access it. You don't have to make it up later on or distinguish between different types anymore. You can just directly use it in the code later. So let's wrap this up. Error classes. Make your own module for it. That's what I recommend. If you make your own module, a private one, then you can just import that in your application and use it everywhere very easily. You explicitly throw only errors that you know about. And that way, you know it's the only source of truth, and it contains all the necessary information to debug your application. Otherwise, we might end up with errors that are not as useful. And I would not know what this actually stands for. I've spoken about these layers where you have to deal with errors. So in those layers, you want to only handle errors there. If you handle errors in place everywhere throughout your code, you have an inconsistent way of dealing with those. But normally, your code is written in a way, let's say you use async await, and you always await all your calls in between. That way, if there is an error anywhere in your chain, in your call chain, it will bubble up until the point where you're able to handle it, until you have this one try-catch. There should normally not be a lot of try-catches in your code. So each layer has one of these try-catches. And as I said, it's like your REST API. That could be Express, Fastify. We have a lot of REST APIs in Node. You have to handle it for outgoing requests and database things. How does it look? How does that actually look in code? So here's an Express example. Express has a way to provide a global error handler. So any error that you explicitly have in one of your routes, you can then handle in that specific error handler. Sadly, Express does not support async await, so I have to use try catch in the route here. And where do we go? There. It's not visible, right? Too bad, it's too high. So on the top, we have await database get data, and then I have to explicitly catch that and return next error. And the error handler is defined with 4 arguments. That's why it's an unused argument in the second part. But here, we are able to distinguish our errors very easily. We just have to check if the error that we received is a user-facing error. And if that's the case, we already know that we provided the status code originally. And now we can use that and access it. And we also want to probably have like a specific error code, so the receiving side knows what this actually stands for. And we are able to also translate it into multiple languages if you're using a code instead of a static text. That's nice. And you don't have to do more. That's pretty much it. Every other error is a 500. Why? Because it is something unexpected. It was something that you did not explicitly throw in your application. That way, we are super easily able to distinguish the types of errors occurring in your application. And we also want to make sure that we always know what's going on in our application, so we log all these things. I give you the same example with Fastify, which has support for async await, and the code now looks even nicer. The main difference is on the top part, because there, we are now able to just throw the error immediately instead of using try catch. That way, in the code is just so simple, I believe every developer would immediately understand it. And the error handler down here has the same functionality. It's just written for Fastify instead of for Express. But we are still just checking for user-facing errors. We are still returning a 500 for all other errors. Databases are a little bit more tricky. So we have to be unique for those, and I don't have a concrete code example because you want to recover in case something bad happens in your application. If one data center is not reachable anymore, you would probably want to transparently just connect to an alternative one. Or if you're having a caching layer and the cache is not warmed up and you receive an error there, you could just and then go to a different route instead, and the user has no idea that this is happening. So this is something so specific to the application that you always have to make sure they are handled properly there. And outgoing requests are pretty simple, actually. I wrote this code a while ago when I had to deal with the Facebook API. And the Facebook API had this wonderful bug where it always returned the 1200 code, and that code means temporary send message failure, please try again later. All right. But not only that, you could also run into network errors while sending out a message to a different API. And in those cases, we probably want to retry. We want to make sure we are recovering as good as possible. So in this case, I'm just retrying a couple of times, until 10 times, actually. And if that doesn't help, then I just give up. Because at some point, it takes too long to give the user still a response. You know, they don't want to have a request like 50 seconds after they called your web page or whatever. What else do we have? So especially Node.js provides you with a couple of debugging utils. And I'm going to go into some details there. I've spoken about the promise constructor, that it's pretty difficult to deal with it. And I recommend to you that you don't promisify any API on your own. It's very error-prone. And instead, you can rely in Node.js on a small helper function. Because this code is a way to legitimately promisify this API. But it can be written with util.promisify in a way simpler way. Here, the code is much nicer because it's shorter. You don't have to worry that anything bad happened in between, because util.promisify knows how to promisify it properly, and therefore there's no more work for you to do. It's nice. There is something like that also for the front end. There is definitely a NPM package that does that. Otherwise, we still end up in these unhandled rejections. Well, unhandled rejections are something that we finally overcome in Node.js, at least hopefully, because you have to provide a flag since Node.js 11 that's called -- unhandled rejections, and if you set that flag to strict, every unhandled rejection is then turned into an uncaught exception instead. Why is that good? Because when you have an unhandled rejection, your application is just continuing to run. But if you're a stateful application, you might end up in errors that are really, really hard to debug later on. And we want to shut off our application as soon as possible and want to restart that application. So we have a fresh state. We don't have to worry about that anymore. And that's what's happening when you have an uncaught exception. So we get that error. The application is going to crash. That's cool. That's what you should do, at least out of my perspective. And V8 helped us recently by implementing something even more awesome. So the main problem in JavaScript is still this async part where our stack traces are not useful. But if you're using async await, from now on, stack traces are going to be useful. And that's super cool. Let's go through it. So I have this function test. And when we await 1, let's go into that. So it's on the top. We have await 2 in here. And then we await awaitable. You can await everything, so also a string. It's just the next tick. And then we throw this error. In an async function, every throw is then turned into the rejection, and it's going to bubble up. So this rejection is then rejected to 1, and then it's rejected to test, and then we are ending in this catch clause. Normally, it would not know anything about the outer functions. Let's look into the stack trace now. We have async 1, async test. We have the correct line numbers where this occurred. This is really, really big. I can highly recommend to all of you to refactor your code to use async await everywhere, because this is going to make debugging so much more easy. You're going to love it. There's some more special cases that are a little bit more tricky. So I've spoken about the promise constructor where it could resolve more than once. But this is all ignored. And Node.js provides you with another hook that you can listen to know when something like that happens. This is not always an error. There's legitimate code that makes usage of this spec in a way as it's written. So when you resolve once in the promise constructor, your promise is from then on resolved with that. It cannot change anymore. So when we resolve again, this is not going to be noticed in your application. The same with reject. When you reject afterwards, it's not going to be noticed. It's just swallowed. But you can listen to the multiple resolves hook, and then you can log that and look into your code if this is actually intentional or not. And most of the time, it will probably not be intentional that you resolve multiple times. This will also catch synchronous errors in the promise constructor after calling the resolve or reject function. So that's pretty nice, and I also hope you can find that useful. This is how it's going to look if you log it. So we know we resolved more than once. The promise that resolved was the first call promise, and the content that it resolved with was swallowed resolve. So now we have the information that was formerly not accessible anymore. The same with the reject call. So we know the second part was rejected, and it is still the same promise, and it was rejected with error swallowed reject plus the stack trace. Cool. Let's just summarize all of the things I've talked about again. please use specific error classes for your application, and only use those. It has to be used by all developers throughout the project, or at least throughout the module that you're using it in. Implement the abstract error handlers that are specific for the part of your application, no matter if it's the outgoing request or the incoming request and so on. And that way, you only have to handle your errors there. You don't have to just put a try-catch here and there and everywhere throughout your code. This makes the code readable, understandable, and more consistent. Use async await because you are making usage of the stack traces that are then helpful for you. Make the errors expressive, so you want to not only have a good error message, but you probably also want to attach multiple properties to that error that might help you even further to debug it, like the status code, error codes, and so on. You can use helper functions like util.promisify. You can use the hooks in Node.js, which then provide you with additional information to debug your application. And yeah, that's it. Muchas gracias.